Okay, so for today, we're looking at just a mix of different transformations that you see in 8th grade. The first is translations, which we didn't really talk about. So I'll explain it real quick. If you need to pause it, if you want to add all this to your notebook, you can. Basically, all it is you just take shape and move it somewhere else. Okay. How we do this algebraically is we either add or subtract to our x and y coordinates, and then it's just all based on the directions. So you know your x-coordinate runs left to right. So if it says move to the left, you're going to subtract from x. If you're moving to the right, you add to x. Same thing for y. If you're going up, you're going to add to y. If you're going down, subtract from y. Okay. Gives you a couple of examples down here. X plus 2, y plus 4 means you went 2 to the right and 4 up. Okay, that's translations. It's not too difficult, but this is the only time. So anytime you have an answer choice and it's got a rule that looks like this has to be a translation. This cannot be any other transformation but a translation. Okay. And then just a reminder, reflections. If we go across the x-axis, x stays the same and y changes. If you go across the y-axis, x changes, y stays the same. So if you don't have that written down and you want to add it next to your translation notes, you can. And then we did rotations yesterday. Remember we said, here's your chart. Stick with that. It'll answer all of your questions. The only other thing you're going to see is dilations. Remember dilation. I didn't copy this down. Dilation just means to multiply. If it's smaller, remember your scale factor is going to be some number less than 1. And if it's getting larger, you just multiply by some scale factor greater than 1. And that's all of dilations. Okay? Have to multiply. If you want to make it smaller, you multiply by something less than 1. If you want something bigger, you multiply by something greater than 1. Okay? That's all you need to answer the questions. Just to give you an idea, though, what did they look like? So quadrilateral shown on the grid, and then they reflected it. What rule describes that? Okay, so reflection, we know either x or y is going to change. It says we're going across the x-axis, and remember our rule says if we go across x, it's all of our y values that are changing. We can also see that if we just pick a point here, like here is 0, 3, and now it's at 0, -3, so we can see we went from xy to x, -y. And then just for fun, you could always go through your other answer choices and see what kind of transformation those are. So if it was x and then y minus 2, that would have been a translation. We've just taken it and moved it down 2 spots. Xy to -yx. Since x and y flip places, we know that's a rotation. What kind of rotation is that? Let's see. -yx. That would be a 270 degrees clockwise rotation or a 90 degrees counterclockwise. And xy to -xy. So if x changed but y stayed the same, that would have been a reflection over the y-axis if we had flipped it from left to right. Okay? But that's all these questions are. It's going to give you a situation and it's going to ask you what is the rule. Not too bad. Okay. That's all I have to say about that.